So today we're going to be discussing about the projectile motion. Last time we introduced the motion in one dimension. It is the horizontal and the vertical motion. The horizontal motion is the motion when you are moving from to the left or to the right. And in the vertical motion is when you are moving upwards or moving downwards. So, projectile motion is a motion in the two dimension. So let me introduce to you the possible scenarios in the projectile motion. The possible curves that you are going to be dealing with in the projectile problems. So the first curve or the first type of trajectory that we are going to solve is when the ball is rolling, it rolls horizontally to the ground and forms a parabola like this. So let me arrange it to make it more presentable. So this one, this is the first type of the trajectory that you're going to be dealing with. At a certain height, your ball rolls to the ground. The time that your object will take until it falls to the ground. The second type of curve we're going to be dealing is when your ball is at the ground. So, most commonly, the object that you are going to use in the projectile motion is ball because it doesn't affected by the air resistance most of the time. So, your ball is thrown at a certain angle like this, and it reaches the ground with a certain range. So range is the distance traveled by the ball in the horizontal. So this is it is the second type of the projectile. Uh, and the third one is the most complicated one for me because at a certain height, your object is thrown at a certain angle and falls to the ground at a certain time and a certain range. And that's the three types of the curves that you're going to be dealing with. So, upon solving problems regarding projectile motion, you must be familiar with the kinematic equation first. Equations, which are the final velocity is equal to the initial velocity plus acceleration times the time, and the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration and the displacement. Um, Another one is the displacement is equal to the to 1/2 times initial velocity plus the final velocity times your time. And the last formula in the kinematic equation is the distance or displacement is equal to initial velocity times time plus 1/2 80 squared. So these equations or the formulas are very useful in solving projectile motion. And sometimes your professor or your teacher will require you to memorize this because you are not allowed to bring your cheat sheet during exam. So it's important for you to memorize these equations. So let's try to solve. No? As I mentioned earlier, when we are dealing with the object rolling at a certain height, it is the easiest one. So let me draw first the problem so you can understand it even better. So this is a drawing of cliff, my cliff. So this is a boulder and it rolls horizontally to the ground. Um, when we say when the boulder rolls horizontally to the ground, it just means that it doesn't have velocity in the y component. It it just rolls horizontally. It rolls in the horizontal component only. So to determine the height of the cliff, we use the formula um, height is equal to 1 half 80 squared. So if you watch my video earlier, a while back, I've discussed the how I come up with this formula, the 1 half 80 squared, to determine the height of an object. Given your height or your time, when you are finding the height, you need to have your time. And when you are finding the time, you need your height as a given. So to solve that, you don't have your height, so you're finding the height. Height is equal to 1 half. Your acceleration is 9.8 times your time, which is 6 seconds squared. So height is equal to um, 9.8 times 1 half is 4.905 times 6 squared is 36. So height is equal to, let me, 4.905 times 36. Your height, the height of the cliff is 176.58 meters. So let me put this on the other side so we can use this space in solving the range. The horizontal distance or the displacement traveled by the boulder. So this is the A. We are finding the B, which is the horizontal. This is the range. So we have the formula: range is equal to Vx, velocity in the x component times times. We can expand this. When you have the angle, we can use the V cosine theta times time. But this time you don't have an angle, it just rolls to the right, just rolls horizontally. So you're just gonna be using range is equal to Vxt. So your range is equal to, we have the velocity, which is the 10 meters per second, times the time, which is 6 seconds. So the final answer is 60 meters. So the range is from here to here. It is 60 meters. And the height, which is from the top to the ground, which is 176. So the final answer is the height is 176.58 meters and the range is 60 meters. So let's try another example. A soccer ball was kicked off the ground at a speed of 12 meters per second. At what angle did the player kick the ball that it landed 6 meters away? So we are talking about the ball is at the ground and kick with a certain angle. So let me draw it first for you to understand it better. So it was kicked at a certain angle that we don't know, and it reaches a range that is 6 meters. So the range is 6 meters. And its velocity, so we name it V because it has a velocity from the y component and the x component. So name this V, 12 meters per second. So let us shrink the drawing. So to solve, we have the formula here in the x component. We have the range is equal to Vx times time. So Vx is, since we have an angle that is missing, or it is sometimes given, we use V cosine theta times time in finding the range. So in this equation, we cannot easily determine the range because the time is not given, isn't given, and so we should use the we should find the value of time in the y component. So let's try to find the value of time in the y component. So we know we know that the highest point, so let's label it, the starting point is point A, in the point when the soccer ball reaches its peak. So it's here, and the point C where the ball landed. So we know for the fact that the point B has a velocity in the y component, final velocity in the y component, that is 0. I already told you that when I was talking about motion in the vertical direction. So let us insert the given Vy final is equal to 0. The acceleration is constant, negative 9.8 meters per second squared. So we have the formula final velocity is equal to the initial velocity plus acceleration times the time. So we substitute the values. So we have 0 Vy initial plus negative 9.8 meters per second squared times your time. So I'm going to move the clear something to for you to so you have your so we have your equation here. So we have our equation here. We move Vy initial to the other side. It will become negative Vy initial is equal to negative 9.8 meters per second squared times time. So we multiply both sides by negative 1. So it will become positive Vy initial is equal to 9.8 meters per second squared times the time. So we are finding the value of time here. So your time here, your time from point A to point B is equal to the initial velocity times divided by 9.8 meters per second squared. So we know for a fact that your, for example, your your time from point A to point B is 2 seconds, then the time it will take for you to reach from point A to point C is 4 seconds because you will multiply it by 2, just by 2. So, time from point A to point C is equal to 2 Vy initial all over 9.8 meters per second squared. We know that the Vy initial, your velocity in the y component can be your Vy initial can be V sine theta because you are dealing in the velocity in the y component. So, change that to V sine theta all over 9.8 meters per second squared. So, this is your time. So, let me remove this. So, and compare it to the component in the the component in the y. So, this time we have the two component in time. Let me move v cosine theta to the other side of the equation. T is equal to range all over v cosine theta. So, let us equate the two equation. It will become r all over r all over v cosine theta is equal to 2 v sine theta all over 9.8 meters per second squared. So, let's cross multiply r times 9.8 meters per second squared is equal to 2 v squared sine theta cosine theta. So, this is now our equation. If you are familiar with the double angle formula, if you really study in your pre-calculus class and trigonometry class, we know that the 2 sine theta cosine theta is equal to sine 2 sine 2 theta. So, let us substitute that to this because you can't know the angle if you use the 2 sine theta cosine theta. So, v squared sine theta sine 2 theta. So, we have now the equation that we need. Let me give you an insight about this. So, r is equal to v squared sine 2 theta all over 9.8 meters per second squared. So, this one is the formula that you are going to use in finding the range. You can memorize this. It's easier for us to memorize this. But I just showed you how it is derived to get the equation of this. Because in physics class, sometimes you are going to use two equation and you will equate it. It will become one equation. You will use your knowledge in algebra. to solve for a problem like this. So let's find the range, or let's find the angle using the given. So you have range as a given, so the range is 6 meters away. The velocity is 12 squared sine 2 theta all over 9.8 meters per second squared. So using your knowledge in algebra, it is called isolation of variables. You will come up with um, 6 meters times 9.8 meters per second squared all over 144 is equal to sine 2 theta. So using this, to remove the sine, you must use the arc sine on both sides. So 6 times 9.8 all over 144 is equal to sine 2, is equal to, sorry, my mistake, is equal to 2 theta. To remove the 2, you divide both sides by 2. So 2. After you get the answer, so the final equation here is theta is equal to sine inverse of 6 times 9.8 all over 144 all over 2. So you can directly insert the values in the calculator. That's why it is required for you to use scientific calculator in the problem like this. So the final answer is 12.05 degrees. So the angle that the player kicked the ball that it landed 6 meters away is 12.05 degrees.